Your algorithm is blazing fast. O of n, clean, efficient, passes every test. Then it runs on real data, and your server runs out of memory and crashes. Speed was never the problem. You forgot to measure the other half of big O. Everyone obsesses over time complexity, how fast code runs, but there's a second cost that interviews test just as hard, and most developers completely ignore. It's called space complexity, and it's about how much memory your code actually uses. Space complexity measures how much extra memory your algorithm needs as the input grows. Not the input itself, the extra stuff you create while solving the problem, new arrays, new variables, recursive calls stacking up. Same growth logic as time complexity, just applied to memory instead of speed. If you're swapping two variables or looping through an array without creating anything new, you're using constant space. Doesn't matter if the array has 10 items or 10 million, your extra memory usage stays flat. Now, say you loop through an array and copy every value into a brand new array. That new array grows exactly as fast as your input does. Double the input, double the memory. That's linear space, and it's incredibly easy to do by accident. Here's the part that trips people up. Recursive functions don't just run, they stack. Every recursive call adds a new frame to the call stack, sitting in memory until it returns. A recursive function that calls itself n times is using on space, even if you never created a single array. Sometimes you can make code faster by using more memory, caching results instead of recalculating them. Sometimes you can save memory by doing more repeated work. This trade-off shows up constantly in real interviews. Can you solve this with less space? Is one of the most common follow-up questions after you get the time-efficient answer. Here's what almost everyone misses. They optimize a solution down to on time, feel done, and never check what it cost in memory to get there. A solution that's fast but creates 3 new arrays along the way might be worse in practice than a slightly slower one that works in place. Always ask both questions, how fast and how much memory, not just one. Space complexity measures extra memory used as input grows, not the input itself. Working in place is O1 space. Creating new structures is ON space. Recursion quietly costs space too through the call stack. Fast isn't the same as efficient. Memory matters just as much. This is video 4 of the full DevVerseX Data Structures and Algorithms course. Subscribe so you don't miss how these ideas connect. Next up, arrays explained. The data structure that quietly powers almost everything else you're about to learn.